Welcome students in chapter 8 application of integration. Students, today I continue our exercise 8.1 question number 7. Yes, one curve and either one line either two line related given to respectively axis area. So find minimum area bounded between the line x is equal to a by root 2 and circle x square plus y square is equal to a square. Students, before starting these solutions, today our numerical, I just inform you, it is a logical numerical. Means you apply your logic and you create the area. Because here given logically, how can define it is minimum? Yes. So students, here x is equal to a by root 2. Line given and circle given x square plus y square is equal to a square. It means this. Center 0 0, radius a0, and that's your x-axis. Here y-axis. I apply a logic 0 to a. It means definitely here middle point is a by 2. A by 2 means half. Students, you know half is a 0.50, and a by root 2 is a 1 by root 2. If you calculate 1 by root 2, it is near about 0.70. It means right side or left side? Yes, right side here. It is a by root 2. That's the logic. Yes, if you a by root 2 is less than 1 by 8, then I write down here. So what's your area bounded between that? Yes, that's the x is equal to a by root 2. So this area is minimum. That is the maximum. I want to minimum. Logic over. That's your area, create your A1. After the double. Yes, double then this one. So don't worry, I only calculate the A1 between a by root 2 to a. That's minimum. If you are asking maximum, then I take that. 0 to a by root 2. But minimum this, that one. Very easy. Now in given curve, what is your curve? X square plus y square, a square. Means y become under root a square minus x square. That is this one. This your curve. Y is equal to under root a square minus x square. So in given curve y and the line x is equal to a by root 2. 2, I taking x is equal to a, and that bounded region is a minimum. So by given curve and the line a by root 2 and x is equal to a, so minimum area a1, I define that, yes, that a by root 2 to a to a by root 2 to a y dx. And very easy that calculation now. Students, a1 I just start a by root 2 to a, and what's your y? Under root a square minus x square. Now simple calculate in the simplifications and you get the answer, students. Yes. So I start my integrations value, that the a1 which is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a, and limit is a upon root 2 to a. Now apply upper limit minus lower limit. So does easily you can create your upper limit a minus a 0 here plus a square by 2, that becomes sine inverse 1. Now time coming to lower limit a by 2 root 2 same, that one. Here going under root a square by 2 and plus same as a square by 2 sine inverse a by root 2 with the a. That's your a and a gone. Here students, that is the 90. So even create your solutions 0 plus a square by 2 pi by 2 minus a by 2 root 2 into a square by 2. Correct? A square minus a square by 2, it is a square by 2, and plus a square by 2. Here 1 by root 2 is a 45, pi by 4. Finally, a1 is done, pi square by 4 minus here a by 2 root 2 into a by root 2. Yes, a square is a by root 2, and that, students, pi square by 8. Now simplify, you can cover your easily data. So my A1 solution is done for pi square by 4 minus a square by 2 2s are 4, and one more minus pi square by 8. That is your taking LCM. So students, my data is covered. A1 integration, it is LCM overall here, students, 8. So I take here 4, sir. So 2 pi a square minus 2a square and minus pi a square. So your data is covered finally. 2 pi a square minus pi a square, pi square minus 2a square by 8, and common taking. Students, my common is a square, remaining are pi minus 2 by 8. That is area square units. For cover only and only this one, but I want to full line, so it take again double. Therefore total area, what? 2 times of a1, 2 times of a square, pi minus 2 by 8, that cancel 4, and in backside answer printed here a square by 4 pi minus 2. That's your final answer. Either you can take 2 extra multiply inside, it means that way, a square by 2 into 2 pi minus 2. So a square by 2, here pi by 2 minus 1. I just multiply inside a square by 4 minus a square by 2. Yes, students, this is your final answer, square units. You can make final, and this is the shortest distance, I mean shortest area, minimum area is done, but this logic is clear about half 0.50, it means exactly 0 to a, and 1 by root 2 is a 0.70, just like above that. Now continue, students. Question number, we going ahead, 8th one. 8th also very interesting, and one of the logical sum. Yes, logic apply and get the answer. Yes, 8 students, IMP. If the line x is equal to a, yes, if the line x is equal to a divide in same area, either in equal area bounded between the curve x is equal to y square and x is equal to 4, then find a. Again repeat, if a line x is equal to divide in the equal areas, it means x is equal to a is a create the equality areas between that the curve x is equal to y square, and secondly just I reading x is equal to y square and x is equal to 4. Very easy. Just first of all, students, you draw our curve parabolic x y origin. This your curve y square is equal to x, completely parabolic first case, just kind of that. X is equal to 4 means here, that's here 4 comma 0, x is equal to 4. Now read that line x is equal to a is divided in equal areas bounded between that. This is a total area. Here divide in 2 parts but equal. It means that's your create x is equal to a. Here a comma 0. So does this area I consider a1, and this area I consider a2, but both area here equal, divide by the line itself, x is equal to a, and find out a. Can you guess what is your 0 to 4 middle point? A is a 2. No, here not is a2, but different from 2 coming here answer, students. So I start the area between a1 and a2 equal. Both of the boundary different, and that's why I take a1 a2 separate and boundary utilizations and get the answer. Students, first area boundary 0 to a, but second area boundary a to 4. Yes, here line x is equal to a, divide the area between, divide in same area, divide in same area, bounded between, yes, parabola y square is equal to x and x is equal to 4. That's why I am taking here a1 and a2 in same positions. So does a1 here 0 to a, that y dx. Secondly, a to 4, y dx. And now you create putting your y. What is your y? Root x. So here root x dx. Same here also, root x dx. 0 to a first limit and second a to 4 second limit. Now anyhow you can make integrations, limit putting. So x raised to, students, 3 by 2 by 3 by 2 and boundary same 0 to a. Similarly here x raised to 3 by 2 a to 4, that also, students, 3 by 2. Now 3 by 2 3 by 2 universally cancel. Upper limit minus lower limit. So upper limit is a raised to 3 by 2 minus 0 raised to 3 by 2. Same here, 4 raised to 3 by 2 minus a raised to 3 by 2. So does this a raised to 3 by 2 and this both club same. So it is a raised to 3 by 2 plus a raised to 3 by 2, and here 4 raised to 3 by 2 as is. Finally 2 times here 2 square 3 by 2, this and this cancel. So you can get 2 into here 2 cube 8. Again they cancel with the 4. Now you get value of a. So a become 4 the power 3 by 2, convert 2 by 3. Textbook answer this given. Done. But sometimes this also valid. 2 square raised to 2 by 3. So 2 raised to 4 by 3. Check. This value is exactly 2. Middle? No, it is more than 2. Yes, just like 2 is here and more than that 2. But this is a confirm and true answer between bounded that x equal to 0 to x is equal to 4. X is equal to a in two areas whenever you a is become 2 raised to 4 by 3. Now students, I continue my question number 9. I hope you understand that type of logical questions, and it's very easy, students. Just apply simple logic. Now continue one more, 9th one. 9 also logical sum. In parabola and line given, find area between parabola given y is equal to x square and y is equal to modulus x. So does modulus x means one of the plus x and one of the minus x. So there are two possibility. Here two possibility, plus or minus x. Parabola known, y is equal to x square. It is your this type drawing y axis, origin x axis. That's your parabola. X square is equal to y. Correct? Now here two lines, y is equal to x, y is equal to minus x. It means this line passing through origin another is this way, and I want to this intersection points A and B, and then after I explaining my start. So students, here y is equal to x square, and can I take y is equal to x? First case, both compare it. So x square is equal to x square minus x 0, x common, it get x 0 or x 1. That case is you easily get y 0, y 1. So this point is clear, it is 1 1, this 0 0. If you put it minus x, then this is also clear, minus 1 comma 1. Now I start explaining this sum. So does between that area, it means this is my target, parabola and line, that consider A1 in modulus. Similarly this side also. So I only calculate one, other is that double, and double taking your answer. Now question is how can define A1. So students, I properly here explain, just you see here and stop your writing. I explain about A1 definitions, just here naming that, here A, same as, sorry, here A written already, so I O, here P, here Q, here M, and here students, one of the parts of O, A, Q, P, M. That point is a 1, 0. I draw here two little figure just to see. I just plotting first of all parabola, y-axis, only parabola draw, only parabola. Point is that A here 1 0, sorry 1 1. Exactly you plot the bottom points M 1 0, that is 0 0, and between that here P. So area bounded between that, it means this one, parabola only bounded. And one more, students, here see, a second draw, I only the line, this line, y is equal to x, x-axis, y-axis. I explaining about both separations, and then after I create my area, second same I explain here, that's your A 1 1, and here M 1 0. This area is a fully big area to converting your 0 O Q A M. So let's look at that. This is a full area O M A Q O, that one minus this area. So definitely that figure and this figure, if you minus, you can get this between this area, this one, and that's my target. So parabola minus line, either line minus parabola. I both separate one by one. So here start area bounded by the curve. What is your curve? Y is equal to x square. So x is equal to, sorry, y is equal to x square between, or your x is equal to 0 to x is equal to 1. Only this case I explain about that, this one, in this region, correct? So that's area is a O M A P, that's the 0 to 1 y dx, 0 to 1 x square dx, it is a x cube by 3, and limit put it should be 1 by 3 square units. Now I start another, here area bounded by the line. Now what is line? Y is equal to x between x is equal to 0 to x is equal to 1. That's area is a, students, O M A Q, 0 to 1 y dx, 0 to 1 x dx, and create your area. So that's your integrations x square by 2, limit 0 to 1. So it is half square units. Now students, wait and watch here easily. This minus this, either this minus that, you get this answer A1. After that I take double, then my answer cover. Therefore area A1, it means only this area, OPAQO. OPAQO, that one. OPAQO is what? First 1/2 minus 1/3, either 1/3 minus 1/2. So it is get 3 minus 2 by 6, 1 by 6. So total area 2 times of A1. Why total here? Because my question is modulus x. So this line and that line, for this line is indicate y is equal to x, and this line is a y is equal to minus x. I double checking. So 2 times of 1 by 3 square units. And here students, our 9 questions is done. Students, this question you also calculate by another way, that not calculate separate, direct taking curve minus line, either line minus curve. So that type question I explaining about. Second one, next one. Similarly students, in same way, but now I go to shortcut. Question continue. 10th one. Find area bounded between one of the curve given and one of the line given. Yes, question number 10. Find area between the curve x square is equal to 4y and the line x is equal to 4y, x is equal to 4y minus 2. Yes students, the same concept and solution also same that. Students, first of all I define both common point. First we define both common points. So x square is equal to 4y, and secondly x is equal to 4y minus 2. So can I write 4y is equal to x plus 2? This 4y you submit that. Yes. So your data is x square is equal to x plus 2, x square minus x minus 2. So 2 ones are, it means x is equal to 2 or x is equal to minus 1. So it is here x2. So what's the y? Y become x plus 2 by 4. 2 plus 2 by 4 means 1. Same is here students, y x plus 2 by 4 minus 1 plus 2 by 4, which is 1/4. It means points are ready to intersection of both. A point you cover 2, 1 and second point cover minus 1, 1/4. Now I draw my figure. Yes, easily I can draw drawing, and after that I start my solutions. So parabolic known, x square is equal to 4y, just like that. This is your axis, origin, y axis, and x square is equal to 4y is that's your parabola. You know very well, here your origin. Roughly draw, don't worry. Students, here y 1/4 and one of the y is a 1. It means just I consider here 1/4. Here 1 approximately. X is a 2 and minus 1, just like here 1, that is a minus 1. Same here 2, that is a minus 2. So very easy. 2, 1 means here exactly your first point A cover 2, 1. Secondly, minus 1 to 1/4. Minus 1 to 1/4 is approximately here. Just like 1/4 is below that. Don't worry. So this point is B, minus 1 comma 1/4. And both join. Then you get the line. Correct? Line is belong only between 2 points. Now the between is area. It means this area. That's my target. But I create same as this are belonging to x-axis, here also belonging to x-axis, and make them naming here P, here O, here Q, here R, and this point is also belonging to MN. Here also two drawing I explain you students. One of the curve and one of the line. What is a line? Y is equal to x plus 2 by 4. According to that. Students, I draw just two figures. Just you listen and properly look here. This is a two figure. This time I draw first line. This is your line. Between that here one of the points, one of the here. This time I draw first line, after that curve draw, because line portion is a big portion. Here minus 1 and here 2. That is 2 comma 1. Point A, N, O, M, B, and here P. This region, if I calculate, minus. Now only draw our parabolic curve. This is your parabolic curve, students. That same are belonging to my respectively axis. That is your 0, 0, that point. Here M, B, next here N, and here A. That only. And point is there, here minus 1, comma 0. That is your 2 comma 0. A point same as 2 1. Students, this only for understanding, don't worry. You just properly understood that this region and this one I calculate. Now this minus that, you can get this middle portion. So very easy. I calculate first line wise. After that I calculate parabolic wise. Either you direct calculate parabolic minus line, same coming. I go to separate integral solutions. So here I go to area bounded by the line. What is your line? Y is equal to x plus 2 by 4. Between x is equal to minus 1 to x is equal to minus 1 to x is equal to 2. So your area is M O N A P B. M O N A P B full area. That is your minus 1 to 2 y dx. Minus 1 to 2 y is x plus 2 by 4. And simple create your integrations. So 1/4 outside, x square by 2, 2x minus 1 to 2, and that solution is a 4 by 2. 2 to the 4 minus here students 1 by 2 minus 2, and that solution I easily here calculate, students. So 1/4 same, here 2 to cancel, 4 and 2 6, minus 1 minus 2 is 1 minus 4 by 2. So finally you are getting 1/4. 6 minus, it is minus 3 by 2. So finally 1/4. 6 to the 12 plus 3 by 2. 6 to the 12 plus 3, and 2 1 minus 4 is a minus 3 by 2. Correct? So finally you are getting, students, here 15 by 8 square units. That done. Now I go to here second case. Continue. Area bounded by the curve What is your curve? Yes, curve is x square is equal to 4y. So y is equal to x square by 4. Between your x is equal to -1 to x is equal to 2. So my area is that what? BMON AP. Just only naming, that is -1 to 2 y dx. It should be -1 to 2. What is y? X square by 4. So it is x cube by 3, 12. Cube 3 by 3, 4th is a 12. A limit putting -1 to 2. So students, here 1 by 12 outside, 2 cube 8, and here -1. It is 9 by 12. So 3 3s are, and 4 3s are 3 by 4. And this both area, students, now what? Subtraction. Because I want to line area related curve area. So finally write down, students, here required area. Yes, that is your area. What? First of all, 15 by 8 minus 3 by 4, and here make modulus and take LCM. Simple. Your LCM is 8. So 15 minus here 2s are 6 by 8. 15 minus 6, 9 by 8. Square units. I written very small here, but don't worry, students, you understand that properly. Either you can direct calculate x square by 4 minus line, you both direct subtraction, and the separation wise, students, also here this done. Now students, after ending this sum, I stop this part, and further explanation, students, I explain in the next part. Bye bye.